Hello, my name is Michael Matthey, and today I will be using a chi-squared goodness of fit test to determine if this d6 is a fair dice. This particular dice is made of bone, so I've always been a little curious if that affected the fairness of it. So for this test, the null hypothesis, H0, is the die is fair, meaning each number on the die has a probability of 1/6. And the alternative hypothesis is the die is not fair, meaning at least one side does not have a probability of 1/6. For this test, I'll be using a significance level of alpha is 0.05. And before we start, we have a couple of conditions we need to satisfy in order to use a chi-squared goodness of fit test. The sample size must be sufficiently large, in this case above 5. Our observations must be independent, and the categories must be mutually exclusive. So I will be rolling a d6 100 times in identical conditions. Therefore, each die roll will be independent and mutually exclusive. And our expected count for this experiment, I'm going to be rolling it 100 times, so with a probability of 1/6 on each die. That leads us to a expected outcome of 16.67, which is larger than 5. So our assumptions for the chi-square goodness fit test are met and ready to get started. So okay. 1, 2, 2, 2, 3, 1, 4. Ooh, I'm not gonna count that one. 2, 5, 3, 2, 5, 1, 6, 1, 3, 2, 1, 3, 3, 2, 6, 4, 2, 3, 4, 6, 6, 4, 4, 5, 2, 3, 5, 6, 4, 4, 2, 1, 1, 4, 4, 5, 2, 1, 5, 6, 2, 2, 4, 5, 6, 4. Let's see where we're at. 8, 16. Okay, we're about halfway. 2, 4, 5, 6, 6, 4, 3, 4, 1, 1, 2, 5, 6, 1, 3, 2, 6, 5, 1, 4, 6, 5, 2, 1, 2, 3. Alright, we're at 79. So that is 21 more. Four. 2. 2. 3. 4. 6. 2. 6. 2, 8 more. 6, 5, 2, 4, 2, 6, 1. Is that it? 25 plus 10 plus 20 plus. I think I have one more. 3. Okay, so after 100 rolls, we have our results. So for number 1, it rolled a number of 15 times. Number 2 rolled a total of 25 times. Number 3 rolled a total of 11. Number 4 rolled a total of 20. Number 5 rolled a total of 13. And number 6 rolled a total of 16. So now that we have our results, I will conduct the chi-squared goodness of fit test. And the way we do that is we surmise for all 6 possible outcomes. We take the observed frequency minus the expected frequency, in parentheses squared, and divided by the expected frequency. I will go ahead and do that now. God bless Desmos. Okay. So 15 for 1, 25 for 2, 11 for 3, 20 for 4, 13 for 5, and 16 for 6. That gives us a final chi-squared value of 7.758 rounded. So now that we have our final chi-squared value, we have to determine our critical value. So, because we have 6 categories, the die can either roll 1 through 6. Our degrees of freedom is 6 minus 1, so 5. And then looking at the chi-squared distribution table for our alpha is 0.05, and our degree of freedom is 5. Our critical value is 11.07. So, if our chi-squared value is greater than 11.07, we reject our null hypothesis, so therefore the die is not fair. And if our chi-squared value is less than or equal to 11.07, we fail to reject our null hypothesis, in which case the die is fair. So, luckily in this experiment, our final chi-squared value of 7.75 is below 11.07, and therefore, this little bone dice I got at the Ren Fair is in fact fair. I had my suspicions about it, but I'm glad to know that the die is fair. I believe that is all. Thank you so much for watching, and I hope you learned